Hello and welcome back to all my subscribers. And if you're not a subscriber, what's wrong with you? Um, Today, this is the next part of my RISC-V assembly programming series. It's not a tutorial because I'm learning, and I'm just sort of dragging you along with me on this journey to learn RISC-V assembly. Now, previously I had talked about a book that I had got from the RISC-V website, and the author very kindly output a PDF for me to read because it wasn't available as a PDF. Subsequently, I found another book by another author for RISC-V programming, and this one is free and available. Let me show you that now. So this is a book by Robert Winkler, and it's available on his website, robertwinkler.com. It's very good. It does exercises. It's got all of the sort of information you would need about loops and arrays and all that good stuff. And he gives you a lot of sample programs that you can use. And it's very well written, and it has a really good appendices as well with references, links, e-system call list, which is extremely useful. Now, this book is available for free, and you can get it, and I'll put the link in the in the description area for you to have a look at. And while we're on the topic of books, I would just like to say that I'm an author, and I don't get any money from Patreon or YouTube or anything. So if you'd like to support the channel, please check out my books on xgipublishing.com. And if you like some of the books, follow the links, buy the books, and it's a win-win. You support the channel, which helps me, and you get a good book to read. So it's all win-win. But let's go back to the RISC-V stuff. It would be interesting for me if you know or have any other additional resources that I could use. Please put them in the comments, because I'm really just collecting up all of the information I can about RISC-V processing, and I'm trying to read all of the books I can to get this into my head and get myself over the line. But I have been working on the program that I described in my series, so let me just show you that quickly. What we've got here is the pseudocode that I've written before, and basically it was call the command line, parse the command line, output the result, and then exit. So it's really straightforward. I had a parse the command line function pseudocode and an output pseudocode. However, I have had to add now a build binary string, because as I mentioned in the last video, it will the printf function will do decimal and hexadecimal, but it won't output binary. So I need to build a string and then output that myself. So that's where we're at with the pseudocode. I have written two of these. I've written the build binary and the output result. So let's just quickly look at that. At the top here you can see I have done the normal string, like you would recognize this from C programming, where I've used %d to show the decimal and %x to show the hexadecimal. And then when I print the string, I'm going to put binary equals and then the string. And then I have created an empty space, a small array for the string called bstring. So let me just jump you down to the main, and you can see that here I'm just loading in 255 in binary. It can be hex, it doesn't matter, the thing will understand it, but I just decided to try all three, and I've left it at binary. I move the value that's stored in A5 into A3 because the value in A5 gets destroyed and I have to reinstate it. I jump to the build binary, and then I move the stored value back into A5 before I call output result again. So let me just walk you through the build binary function. Now, build binary, the first thing it does is it just initializes the size of the binary string, and it loads the pointer to the address of the string where I'm going to build up. And then it loops through the number to convert to a binary string. So the first thing it does is to check if we've completed and we can quit. So it checks A5 is 0. If it is now 0, if it has become 0, then it goes to end convert. Or if T is 0, which is the string length, is 0, then it goes to end convert. So if either of those are true, it goes to the end convert function. But then the very first thing it does is it does and I, which is bitwise and then immediate instruction. So this takes the number, does a bitwise and then this bit is converted into ASCII, either a 0 or 1, by adding the ASCII value of 0 to it. So if it's 0, it stays 0, and if it's 1, then it adds another one to it. And then it stores that character into the string. And then it shifts the number in A5 right, by 1 bit, effectively dividing it by 2. And then it moves to the next character in the string. And then it decrements the counter, and then it goes back to the top, jumps back to the top. And continues to do that, slowly building up the string. And then when it gets A5 is equal to 0, in other words, we're done with the number, or T0, we're done with the string, then it comes down here to end convert, where it just adds, it just null terminates the string. So it just adds 0 to the string. And then it returns from this function. Now, when it returns from this function, it has obliterated A5 because it's shifted it down to 0. So we need to move the stored value that was input, and in this case it's just a hardwired input, into A5 before we call the output result. Now we call output result, and it just decrements the stack pointer for space, and then it stores RA, and it stores the value in A5. Now, this is important. I didn't do this initially, and it caused me lots of headaches and lots of tracing and lots of GDB work to figure out what was going on. But basically what happens is the printf function destroys all the A registers. And so you have to store this on the stack and then replace it later. So anyway, we set up the arguments for the bin string, which, if you remember, is the one that says binary equals and then the string. We set up move the pointer, and then we load the pointer, and then we move the pointer address into A1, which is the argument. So A0 is the call to printf, the string that we want to print, and A1 is any argument. So we call printf, and it prints binary equals, in this case, 1, 1, 1, 1, 1. And then we have to restore the value back into A5. So we take it back out of the stack pointer and we put it back into A5. And then we call the second printf statement, which is just the basic C equivalent, where you have, we load the address. The first argument is the integer that we're going to print. The second argument is A5 as the hexadecimal that we're going to print. And then we call printf, and then we load back the stack, and we increment the stack pointer, and then we just jump straight to exit, because at this point we're done. Like, we've printed what we need to do. So if we run that now, you can see that it just prints out the binary, and it prints out the hexadecimal and the decimal. So that all works fine. The next bit of the code that needs to be written will be the creation of the command line parsing and any error messages and things. So if you notice in that, when we did the binary build, there is a problem, there is an edge case issue, and that is if the user inputs a 0, because remember that we're shifting the number down, and as soon as it sees 0 it quits. So if we were to call that, if the user put in 0 and we were to call that, it would just immediately put nothing in the string. So that doesn't work. I need to add for that particular edge case. It's relatively straightforward because you can check for it in main, and if the user has entered 0, just print out zeros. So, for all 3 values. But that is an edge case that we will need to take care of. In the next video, I'm going to be working on the command line parsing of how we're going to check the command line and get the value from the user and move on from there. I hope that this is helpful for people. I mean, I'm just doing this to teach myself, but I'm hoping that following along with me is helping you out, and you can work your way through it. If you are already an expert in RISC-V assembly language programming and you spotted something that would help me or be better or clearer or faster or work more efficiently, please put something in the comments and let me know where I've gone wrong or where I could improve or help, because as I say, this isn't a tutorial from a guy who knows everything. This is just you sort of following me along on my haphazard journey to learn RISC-V assembly. Right, if you like this sort of thing, please like and subscribe and share it around to all of your RISC-V assembly programming buddies, and I will see you soon. Bye.